Okay, this is 2.6 continued. So we just went over the congruent supplements theorem, and then theorem 2.5 is the congruent complements theorem. It's very similar, except it states if two angles are complementary to the same angle or congruent angles, then those two angles are, see if you can fill in the blank while I'm writing this down. And then again, you have to remember the definition of complementary angles, even though it's a congruent complements theorem. If two angles are complementary, then one angle is a complement of the other. Two angles are complementary to the same angle. Or if they're complementary to two congruent angles. Then, to figure out the rest, those two angles that are complementary to the same angle would be congruent. I think going back to the congruent supplements theorem, you can just change one word in that and then come up with a congruent complements theorem. So here's my example. If I have one angle, I'm going to call it angle P. Let's say it's 30 degrees. So if I take the complement of that for angle Q, if P and Q are complement, then angle Q would have to be 60 degrees. 60 degrees plus 30 degrees is 90 degrees. And then if I have a third angle, angle R, it's also complementary to angle P. It would have to be 60 degrees as well. So these two angles, Q and R, are complementary to the same angle, angle P. Therefore, Q and R, those angles are congruent. Again, this would be the correct way to write it. Angle Q, not the measure of angle Q. I would write the measure of angle Q as 60 degrees, or the measure of angle R is 60 degrees. Their measures would be equal, but then the angles themselves are congruent. So angle Q is congruent to angle R. Again, you have to write everything correctly, every little part. And I'll mention this as well. I don't think I mentioned it before. When we first started talking about, conditional statements, we could determine whether a conditional statement, the converse, inverse, and the contrapositive were true or false. If it was false, we would be able to provide a counterexample. But here, if we're given a conditional statement that's either a theorem or a postulate, it's already true. You don't have to think about it and determine whether it's true or not. If you're given something as far as a theorem, a postulate, or even a definition in if-then form or as a conditional statement, it's true. All right, moving on to postulate 2.8. So if you don't notice, we're kind of switching between theorems and postulates here. The linear pair postulate. So first of all, you have to remember what a linear pair is. If you didn't believe me before when I said there's a lot of terminology, there's a lot of writing, there's a lot of things that you have to remember in geometry. To be able to understand the linear pair postulate, you have to know the definition of a linear pair. So a linear pair are just two angles that are adjacent, whose opposite rays form a line, hence linear pair. Okay, so if two angles form a linear pair, then they are supplementary. And that kind of should make sense as far as they form a linear pair, they make a line. A line, as far as the angle, would be 180 degrees. So the two angles that make up the linear pair add to 180 degrees. Therefore, they are supplementary. I'll go through an example and draw a diagram in a minute. So I have two angles that form a linear pair. I'm going to just call them angles 1 and 2. They're adjacent. They share a common side, and their opposite rays form a line, this line right here. So this line would be 180 degrees. Actually, it doesn't matter what the measure of angle 1 is. The measure of angle 2 would add to the measure of angle 1 to equal 180 degrees. So if they're supplementary, their sum, this would be the measure of angle 1. And like I said, it doesn't matter what the measure of angle 1 is. It could be something like 110 degrees. It looks like it's obtuse. Then angle 2 would be 70 degrees, but the measure of angle 1 plus a measure of angle 2 would have to equal 180 degrees. And then the last theorem in 2.6, the vertical angles congruence theorem. Again, you have to remember what vertical angles are. So vertical angles are formed by two intersecting lines. If you're not counting like 180 degree angles, there's 4 angles in that diagram. I'm just going to number them 1, 2, 3, and 4. So vertical angles are non-adjacent angles formed by intersecting lines, two intersecting lines, sorry. So angles 1 and 4 can't be vertical angles because they're adjacent angles. Same thing with 3 and 4, same thing with 3 and 2, or 2 and 1. 1 and 3 are vertical angles because they're a pair of angles formed by two intersecting lines that are non-adjacent. And then angles 2 and 4 are vertical angles as well. So the vertical angles congruence theorem, and I think we went through an example without actually talking about the theorem, but vertical angles are congruent. So what I mean by that is angles 2 and 4, those are vertical angles with each other in this diagram. Those two angles are congruent. Angles 1 and 3 are vertical angles with each other. Those two angles are congruent. Just because 2 and 4 are vertical angles with each other doesn't necessarily mean that they're congruent to angles 1 and 3. 2 is not a vertical angle with angle 3. 2 is only a vertical angle with angle 4. So by the vertical angles congruence theorem, angle 4 is congruent to angle 2, and angle 1 is congruent to angle 3. But again, angle 4 is not congruent to angle 1. Angle 2 would not be congruent to angle 3. In special cases, they would be congruent. If you think about it, you might be able to figure out what special case by two intersecting lines where all of the angles would be congruent. These would have to all be right angles or 90-degree angles. But if you just think about one angle measure in that diagram, if I labeled angle 2, made that 100 degrees. 1 and 2 form a linear pair. So by the linear pair postulate, angle 1 would have to be 80 degrees. Angles 3 and angles 2 form a linear pair. So angle 3 would have to be 80 degrees. Since these two angles are supplementary, the supplement of 100 is 80 degrees. Same thing with angle 1. I didn't mention that a minute ago. And then angle 4 and angle 1 form a linear pair, or angle 4 and angle 3 form a linear pair as well. So the supplement of 80 degrees, 100 degrees. As you can see, angles 1 and angles 3, since those two angles are vertical angles, they're congruent. Angles 4 and angles 2, those two angles are vertical angles. They are congruent as well.